How bad? You just need to snuggle up with a blanket on the couch? Yeah, maybe. Everybody okay with this so far? Just take each one, set them equal to 0. So far, so good there. Okay, then you had to describe. So we can see that the highest exponent is a 3. 3 roots, 2 terms, 1 inflection point. Put it in your calc if it helps you. Left side down, right side up. It's a cubing function. Domain and range are both all real numbers. This is nice about the cubing function. Find your relative max, relative min. Take the average of the x's, and then find the y. Everybody okay with concavity? We were turning down here. We were making a turn down, and then we were making a turn up. So where did we cross? Right here. So we have to share that one side of that function. So we take the average, we find the midpoint. We concave from negative infinity to that x value, negative 2. Then from that negative 2 to infinity, we concave up. Kind of make the motion with your finger, concave down, concave up. Right? Concavity is different than increasing, decreasing. Increasing goes up to the point that it turns, decreasing, increasing. Make sure you keep track of relative versus absolute. Stop me if you have any questions. This is a new concept with the concavities. Okay, if you multiply these out, t squared, you would get t to the 4th, 4 roots. That negative in front is causing it to turn down. That means both ends will come down. 3 turns, 2 inflection points. Now, because this is symmetric, so you can see it right here. This is symmetry over the y-axis. This is an even function. So because this is symmetric, when you find this, you can pretty much know what that one is. Concavities, God bless you. We had a relative min over here. Make sure you mark your relative min. These guys are absolute maxes because your y is at the absolute max it can be. Put on the inflection points. Take the average of the x's. That's all it is. Then go to your calc, just do a calc value and get the y. On something like this, it does work out, but just put it in your calc. It's a lot easier. Actually, no, it doesn't. So you have to, where is the point? So you have to go to your calc and get it. Questions? Just a little extra steps. We just keep adding these little extra steps. This is a good way to start with the pattern. Find your highest exponent. 1 down is the turn, 1 down is the inflection point. So then you know what you're looking for overall. And then this guy, excuse me, we have the highest exponent of 3. So 3 roots, 3 zeros, 2 turns, 1 inflection point. Domain and range, nice, all real numbers. And I don't think I asked you domain and range, did I? Did it say domain and range?
It never said anything.
Oh, it didn't say anything?
No,
Sketch and describe. When it says sketch and describe, just do the exact same things that we do in class. Yeah, it's the same thing that we do in class. Because I took these out of your books, and I probably didn't do a great job with the instructions. I should review them this year, because last year I had to make up all sheets. On inflections, make sure you take the average of the x's, put it in your calc, find the y. An inflection point has an xy point. So here's the difference. This inflection is an xy. When we do concave up and down, we're only using the x values. But you still have to find the y because it's an inflection point. So you're still going to have to find me the y values. Does that make sense? Don't give me the inflection as just an x. And the last one, kind of messy looking. Take all those x squared times x times 2x. You get 4x to the 4th. you have an even number out front. Both ends are going to go up. There's no symmetry here, so you're going to have to work those both inflection points. This is probably the messiest looking one. Do your absolute, and here's your absolute min. This is a relative min. This is a relative max. The end points are going up. Okay. There's no double roots. Actually, there is one double root. This one. This is a double. It bounces off. Find the inflection. Take the average of the x's. Over here, average of the x's. So you got a lot of concavities going on. You got a concave up to here. From there, you got a concave down right in here. From there, you got a concave back up again. The inflection point shares it. It says, okay, I decide to turn down. Oops, I changed my mind. Halfway through, I'm going to turn back up again. It's kind of like saying I got to give it a little bit more time than just turning at a high point or a low point. Three decimals, make sure you give me 3 decimals. I'm going to start taking off if they're not 3 decimals. Up to now I say 3 decimals. That we're going to get a little tougher on. Questions? This is the last one, right? This is the last one? We were going to do a divide on this. A long divide. You guys learned long divides, right? You learned this?
No, honestly. You take that X out.
Did you learn a long division like this?
No.
No?
A little bit.
Okay, so first thing through, we're going to do a long divide. We're going to do a long division, and then we're going to do a synthetic division right next to it, and see why synthetic division actually works. So when you do a long division, it's the same as if I did a big long division. I take the first one and I say, front end, what times 12 gives me 45? What times x gives me x to the 4th? X to the 3rd. So I put an x to the, oops. I'm going to have to leave a little space over here with a 0 here. Sorry about that. 0x to the 3rd. Sorry about that. Because it needs a space holder because there's nothing there. So we're going to put the x to the 3rd. Now, once you did this, you say, well, it doesn't go in 4, but it goes in 3. You multiply down, right? Long division. You're going to multiply down. 3 times x cubed, 3x cubed. X cubed times x, x to the 4th. Now the next thing you did in your long division is what? Subtract. So you subtracted this, and then you brought one down. So I've got to subtract this. But I've got to subtract this whole thing. Not just the first term. I've got to subtract the whole thing. So I have to say, take the opposite of this guy, take the opposite of this guy, and add. These come out. And what is 0x cubed and negative 3x cubed? Negative 3x cubed, and I got to bring down this guy. And again, remember your front end division. So if by the next step I say is what times 12 gives me 96, I say what times x gives me negative 3x cubed. Negative 3x squared. I multiply down. Negative 3x squared times 3, negative 9x squared. Negative 3x squared times x, negative 3x cubed. And again, the pattern repeats. I subtract. When I subtract, I take the opposite of all these terms. I take the opposite of this guy, the opposite of this guy, and I add. This comes out. I have negative 10x squared minus 9x squared. Sorry, a negative 10x squared and a positive 9x squared. What does that give me? Negative x squared, right? I have a negative 10 and a positive 9. I bring down the next one. And I do this again. I say, what times x gives me negative x squared? Negative x. Negative x times 3, negative 3x. Negative x times x, negative x squared. Subtracting, I take the opposite, and I add. Last, I bring down the 4. This is long division. And then right next to it, we're going to do synthetic division. You should do the long division with you first to see what it is you're exactly doing. Because when you go do your long division, you have to work each one of these things out. When you take a synthetic division, you're going to actually see why we use synthetic division. So if I put this in, what times x gives me x? 1, right? Because there is no other thing. It is x, so I'm just going to multiply it by 1. So I bring this down, and I bring this down, and I subtract. This becomes a negative, this becomes a negative, and I add. So I have a remainder of 1. So in this thing, when you got all the way down here and you had a remainder of 5, back in the day, what did you do when you first learned remainders?
You put a little R.
You put a little r, so we did the little thing with the r5, and then our next step was to do what with it? Make it a fraction, not a decimal yet. Then we didn't learn decimals yet, so then we learned fractions, and we did this, right? And then to check it, way back in the day, first thing you did was the r, next thing you did was the fraction. And when you checked it, you took this thing times this, and then what did you do to the 5? How did you make it come back to this answer? There's more than this, I just skipped all the spaces. You took this thing times this, and then you added back the 5 to get this, right? That was your check. So this guy now, we have a remainder. We have 1 over x plus 3. So we're just going to put a little plus sign here. It's a long way to get there, isn't it? So now, we're going to do your handy-dandy synthetic division. Now, synthetic division says, pull out every coefficient. But just like this, everybody needs to have some kind of representation here. So we're going to start at x to the 4th. And you're going to say, pull out the coefficients. So x to the 4th has a coefficient of 1. Do we have an x cubed? Nope, so we have to put a 0. We need to account for everything all the way down, and I'll show you in a second. X squared has what coefficient? Negative 10. X to the 1st has what coefficient? Negative 2. And x to the 0 has plus 4. Okay? Now, before you start, make sure you have all the spaces. So your highest is 4. Count it down. 4, 3, 2, 1, 0. This is like x to the 0 here. Just make sure they all have one. We have to put the 0 just like we have to put the 0 here. We need a space holder because otherwise I forgot to count that term in there. So now this is being divided by x plus 3. So if I took x plus 3 and I set it equal to 0, this is my factor. What is my root? Negative 3. So I'm going to put my negative 3 right here. Good so far? Now watch how fast we go through this. We bring down the 1 because we kind of need a starting point. We bring down the 1 and we multiply from left, go to the right. Multiply to the left, to the right. Left to right. So we're going to say negative 3 times 1, go to my left, is negative 3. So we add down. 0 plus a negative 3 is negative 3. Left to right, multiply. I multiply from my left, get my answer, go to the right. Negative 3 times negative 3 is 9. Add down. Negative 1. left to right. Negative 3 times negative 1 is 3. Add down. Negative 3 times 1 is negative 3. Add down. 1. Now, I want you to look at this, and I want you to look at all the coefficients of these guys. Don't we have them all? We have all your coefficients. Now, the tricky part is filling them in. So this is what I want you to do. Front end division. X to the 4th over x gives me what left over? X to the 3rd. So we start here with x to the 3rd. These are my coefficients. I'm just going to put a 1 in here. 1x to the 3rd minus 3x squared minus 1x plus 1. And I notice this must be my remainder because I'm done. All my x's are gone. My x to the 0 is this 1. So my remainder, I say plus 1 over, take my denominator, x plus 3. Isn't that the exact same thing we got with your long division? Which was easier? Synthetic. Synthetic pulls out all your coefficients and just returns you all the coefficients of the result. But then we just have to go back and do a little front end to see where should we start this. If it was an x cubed over x squared, I'd start it with an x and then work myself down. This is why we do synthetic division, so that we don't have to do all of that. Now, synthetic division has a couple of little snags in here, and I'm going to try to give you a couple of examples of the snags. I have a couple of them. Now, the leading coefficient of any time you start has to be a 1. In synthetic division, the leading coefficient must be 1. We're also going to see if we take 3 terms, we're only going to do the last 2. That's a special case in itself. So I want to work out another one where the leading coefficient is not 1. You guys okay with this so far? Okay. You'll get the hang of it. God bless you. So now this guy, we're going to pull out your coefficients. If there's missing a coefficient, put a 0 there. The only signs you have to really put down are your negative signs. So the first coefficient is 6. Then what? Then what? Then what? Good. So I'm just going to count down to make sure, because if this is the part I mess up, everything is wrong. And there's no easy way to go back and just correct that. You got to do it all over again. So this started with x3, x2, x1, x0. So it looks like we got them all. Now here's our divisor. Our divisor, right? I need this to be 1. So what should I do for that? Factor out a 3, right? So I get what? X minus 2/3. I know it's a fraction. I gotta use this guy. This is what I'm gonna set to 0. And I'm gonna have to remember this, that we factored this out, right? Because the factor, we can't get rid of the factor. The factor has to stay with us. On your paper, mark it somehow, because this is the part that I skip. Because by the time you get through everything else, you forget to go look back at this. So put a little asterisk next to it so that it reminds you to go back. And the rest will work out. So we're going to divide by this guy. All right, so bring down the first one. What is 6 times 2/3? 4. So multiply from the left, move it to the right. Add down. I'm going to get a negative in here. What is 2/3 of 12? Negative 8. I'm going to add down. I'm going to multiply from the left to the right. 2/3 times 9. 6. I'm going to add down. What do I get? 0. Now, we're going to see when we do this again and again. This, when we get a remainder of 0, means this is a factor. If I was to put this in my y equals and I looked for my zeros, 2/3 would be a root of my equation. That's a factor. That's what this 0 is going to tell us. But now I need to write this out. So I start front end. And before I write this out, I need to come back and say, well, we factored out of 3. We have to factor out of 3 out of here. This is why I say put an asterisk around that thing, because you forget to come back and do this. So I have to factor a 3 out of everybody here. So if I factor out of 3, I get a 2, -4, and a 3. I still get my remainder 0. Front end says x cubed over x. What am I going to start with? X squared. 2x squared minus 4x plus 3x to the 0 just gives me plus 3. Okay? Now, if I multiplied this thing times this, I would get the result. And you can do this, but a quick way to do this is watch. Do your first terms and your last terms. This is my 6x cubed. This is my -6. If I had a remainder, this is where I would add it back here and see if it works. If these work, chances are the insides work, but you can multiply the whole thing out and make sure that it works. Okay, make sense? So it's a whole lot easier than doing a long division. This is technically why we use synthetic division in this course, because pretty soon I'll give you a messy looking thing like that, and I'll even go up to the 5th root or so and say, find me all the roots to this, all the zeros. And other than that, you're not going to be able to factor those. Grouping doesn't work. They're not perfect cubes. I'm not going to be able to factor it. So what we're going to do is go into our calculator, find a 0, and we're going to start with that. And eventually we're going to get down to an x squared, and our x squared says factor this. So if I was looking for all the factors of this, and I found out that this in fact is a factor, I know one factor. I know this is true. Now to find my other one, I would factor this guy. Well, if I need to do a times c, if I need to do the quadratic, I can still do this. Once I get down to a square, I can factor anything, right? I have to complete the square, anything like that. And so this is what we're going to be using this for. Today's lesson is just to get you used to synthetic division. But I always like to say where we're going with this, because then it starts to make a little bit more sense. So you guys probably did a synthetic division, but probably didn't use it to find roots, right? You just synthetically divided. So once you start using it to see where the roots are, I think it makes a whole lot more sense. Questions? Okay, here comes the tough one. Now, we always use the last, here's another situation for synthetic division. The leading coefficient has to be 1, which it is, right? We always use the last 2 terms. And your leading coefficient must be 1. Okay, sometimes you get to divide like this. Excuse me. Excuse me. You see this? Expand this. What's missing from here? An x. So expand this. So the leading coefficient is 1. I'm going to use these two terms. So one thing about synthetic division, your leading coefficient must be 1. And if there's more than 2 terms, we're going to use the last 2 terms. We're going to do this with a double divide. This one's a little tricky. So the first time through, all I want you to do is watch. Then I'm going to do it again, and we'll do it together. But the first time, if you're writing and trying to figure it out, you're not going to find the pattern. And the pattern, once you get it, is a piece of cake. So let's pull out your coefficients. What are they? 1. So let me try. x3, x2, x1. I need an x0. So what should I put here? 0. I need a space holder for every x from 3 all the way down. When I take this, I take the opposite of these both terms. I'm going to get a 3 and a -1. We're probably just going to be able to do this, and then tomorrow we'll do this again. So all I want you to do is watch with me. We're still going to multiply from left to right, but we've got 2 things to multiply. So we're going to start like this. We're going to bring the 1 down. We're still going to multiply from the left, take the left-hand 1, 3 times 1, and move it to the right. But we're not done because we didn't do the -1. So we do -1 times 1, and I got to move it to the right, but somebody's there, so I'm going to move it right next to them. -1. I'm going to stop and just add this row down. So when I add this row down, I get a 1. I'm going to do it again. From the left, 3 times 1 to my right, 3. -1 times 1 to my right, but somebody's there, I got to go over here. And I stop. Now, because I'm at the end, I can add both columns down. If I had another column, I would just add this one down. So if you add these down, you get 7 and -1. Now, the highest is x3 over x2. So what am I going to start this guy with? X. 1x plus 1. So I'm done. So this must be my remainder. Work your remainder backwards. This would be x0. This would be x. We're going to go over this again tomorrow because I think we're running out of time. So tomorrow we'll hit this one again. But I want you not to panic over this. Tomorrow we'll walk through each step. On the homework, if you have a double, just leave the double blank. Okay, and we'll do those tomorrow in class. So tomorrow I'll walk through the pattern. Try to look at it again tonight just to see if it makes sense. But the only thing is pulling up those 2 terms, the opposite. The quiz is just sketching it.